Have you ever wondered what secrets lurk beneath the surface of the world's tallest mountains? In this video, we explore an extraordinary discovery at one of the most mysterious places on the planet. What has left scientists baffled and sparked heated debate in the scientific community? Join us as we uncover the untold secrets, facts that could change the way we view the natural world around us. Don't miss your chance to discover the truth with us. The Large Hadron Collider, a giant microscope. In July 2022, something went horribly wrong at Centre Européen de Recherche Nucléaire. Scientists working with the Large Hadron Collider, a giant machine that smashes particles together, ran into a shocking and completely unanticipated problem deep underground at the border between Switzerland and France. This was no ordinary glitch. It challenged everything we thought we knew about the universe. At CERN, the European Organization for Nuclear Research, scientists are delving into one of the universe's greatest mysteries. What is it composed of? To investigate, they use the Large Hadron Collider, LHC, an enormous machine that functions like a powerful microscope, revealing the universe's smallest components. In July 2022, during routine experiments, the team encountered an unexpected anomaly. This discovery challenges our current understanding of the universe and suggests that there might be more to learn. The LHC, which was first operational in 2008, spans the Swiss-French border underground. It has been pivotal in advancing our knowledge of fundamental particles by colliding them at extremely high speeds. Despite its sophistication, the LHC is not immune to issues. Operating at maximum energy levels, it recently faced a significant problem. This incident underscores that even the most cutting-edge scientific instruments can encounter unforeseen difficulties. Yet, these challenges may lead to groundbreaking discoveries, potentially altering our perception of the cosmos. This anomaly might provide insights into the unexplored aspects of particle physics. As scientists continue to explore and address these challenges, the potential for new discoveries grows, highlighting the ever-evolving nature of science, where each answer brings new questions and possibilities. CERN, a legacy of scientific collaboration. After World War II, there was a need for cooperative scientific research in Europe. Physicist Louis de Broglie proposed the idea of a European laboratory in 1950. This idea was welcomed, and soon, in 1952, CERN was founded by 11 countries. Located on the Swiss-French border, CERN initially focused on studying atomic nuclei. But over time, their ambitions grew. By the 1980s, scientists realized the need for a more advanced tool to explore the fundamental properties of matter, leading to the development of the Large Hadron Collider. CERN's projects, including the LHC, have grown in scope and ambition, reflecting the increasingly complex questions scientists want to explore. The creation and evolution of the LHC represent a major leap in technology and collaboration in physics, aiming to understand the building blocks of the universe. Each new finding from the LHC helps piece together a clearer picture of our cosmos, guiding the next steps in understanding the vast universe around us. Particle accelerators, such as the Large Hadron Collider, LHC, are sophisticated machines designed to accelerate particles to nearly the speed of light, causing them to collide. These collisions enable scientists to explore the fundamental building blocks of matter. The concept of the LHC emerged in the 1980s with the goal of creating the world's largest and most powerful particle accelerator. The LHC, boasting a 27-kilometer circumference, is equipped with cutting-edge superconducting magnets and advanced detection systems. Now, let's explore the incredible feats of human ingenuity achieved deep underground. The LHC's detectors and experiments. The LHC has 7 advanced detectors that monitor these particle collisions, capturing the chaos of particles smashing into each other at nearly the speed of light. This allows scientists to study the particles and forces at play in these tiny yet crucial moments. Typically, the LHC experiments involve colliding protons, but sometimes they collide heavier particles, like lead, to learn more about other aspects of particle physics, such as the Higgs boson and potential new particles. Despite its significant contributions to physics, the LHC has faced technical challenges. In 2008, a major malfunction in one of its magnets temporarily stopped operations. But these setbacks haven't stopped the LHC from achieving important milestones, like discovering the Higgs boson in 2012. But this wasn't the only challenge. The ongoing work continues to test the limits of what we know. The LHC is now in its third operational phase, which will continue until 2025. This phase is crucial for new discoveries, with plans for upgrades to improve its capabilities. Don't take your eyes off the screen because we're about to unveil some startling information. A decade with the Large Hadron Collider. The Large Hadron Collider, LHC, has been a cornerstone of scientific exploration, serving as a powerful tool that acts like a giant microscope, enabling scientists to investigate the universe's most minuscule components. This colossal instrument has been pivotal in enhancing our comprehension of the fundamental elements of the cosmos. The dedication and effort invested in these endeavors underscore humanity's deep commitment to uncovering the mysteries of existence, even as the universe itself often appears indifferent to our inquiries. Throughout most of the year, the LHC's primary function is to collide proton beams. However, for a month each year, scientists switch to using heavy ions, such as lead, in their experiments. This deliberate change is essential for delving deeper into the intricate world of particle physics, a discipline filled with complex and abstract theories. The continuous effort in these experiments is driven by an unyielding curiosity about the universe's smallest building blocks. A notable milestone achieved by the LHC was the confirmation of the Higgs boson between 2009 and 2013. This discovery was crucial in understanding why particles have mass, marking a significant advancement in physics. However, the LHC's mission extends beyond confirming known theories. It also aims to discover new particles, potentially predicted by theories such as supersymmetry. Unveiling these particles could shed light on dark matter, a mysterious and invisible substance that constitutes a large portion of our universe, yet remains undetectable and poorly understood. The LHC's work, therefore, is not only about affirming established knowledge, but also about pushing the boundaries of what we know, potentially leading to groundbreaking discoveries that could transform our understanding of the universe. Deep within the Large Hadron Collider experiments, the focus is on hadrons, tiny particles that consist of even smaller parts. These experiments are not merely academic exercises, but are critical to expanding the boundaries of scientific knowledge about the universe. Each experiment carries potential implications for both confirming existing theories and possibly overturning them, requiring scientists to constantly evaluate and re-evaluate their understanding. This rigorous scientific inquiry is driven by a profound dedication to uncovering the fundamental truths of our universe, challenging researchers to refine their theories and approaches continually. The LHC's challenges and achievements. Quarks are fundamental particles that make up the protons and neutrons within an atom's nucleus. These tiny particles are essential components of the universe's structure, and studying them requires highly advanced technology, such as the Large Hadron Collider, LHC. However, the journey of the LHC has been challenging. Shortly after its launch in 2008, the collider faced a significant setback when a malfunction occurred in one of its magnets. This technical failure caused a major disruption, halting the LHC's operations for over a year. This incident highlighted the complexities and potential pitfalls of managing such an advanced and delicate scientific instrument. Despite these early obstacles, the LHC made remarkable progress. In 2012, it achieved a groundbreaking milestone by confirming the existence of the Higgs boson, a particle that had long been theorized but never observed. The discovery of the Higgs boson was a crucial validation of the standard model of particle physics, a theoretical framework describing the fundamental particles and forces that govern the universe. This discovery not only confirmed decades of theoretical work, but also opened new pathways for understanding the fundamental nature of the universe. As the LHC continues to operate and provide new data, it remains a vital tool for groundbreaking scientific research and a testament to human determination. Its ability to unveil aspects of the universe that are invisible in everyday life is unmatched. However, the collider also serves as a reminder of the inherent challenges in scientific exploration. Each discovery is often preceded by numerous setbacks and requires relentless problem-solving. The LHC embodies the dual nature of scientific endeavors. They are both enlightening and demanding, pushing the limits of human knowledge and testing the bounds of human ingenuity. As we continue our exploration from the depths of the Earth to the vastness of space, the LHC stands as a symbol of our relentless pursuit of understanding. It showcases the incredible achievements we can accomplish through dedication and collaboration, while reminding us of the complex and often arduous journey of scientific discovery. The work done at the LHC not only expands our knowledge of the universe's fundamental particles, but also inspires future generations to continue exploring the unknown. The Large Hadron Collider. Pursuit of the Higgs boson. Each collision inside the Large Hadron Collider is a small-scale cosmic event, producing vast quantities of data. This data is meticulously processed using advanced detectors and computing systems, which help unravel fundamental truths about how matter and energy interact at the most basic level. The data production of the Large Hadron Collider is immense, amounting to about 15 petabytes each year. To handle this, an impressive global computing grid was established, representing a significant achievement in technology. The primary focus of the Large Hadron Collider is the Higgs boson, a particle that had been predicted by theorists but remained unobserved due to its large mass and fleeting presence. The Large Hadron Collider was specifically designed to detect several Higgs bosons every minute, much like setting a trap for a rare, almost mythical creature that many believed in but had never seen. The successful detection of the Higgs boson marked a monumental moment in physics, confirming theories that had been discussed for decades. Beyond the Higgs boson, the Large Hadron Collider also seeks other theoretical particles, such as those proposed by the theory of supersymmetry. These investigations challenge our understanding of the universe's fundamental forces and push the limits of current scientific knowledge. As Centre Européen de Recherche Nucléaire continues this ambitious exploration, it is effectively expanding our comprehension of the universe's underlying structure. The journey of the Large Hadron Collider is filled with high stakes and significant expectations as it strives to expand the frontiers of science. Yet, one might question whether the portrayal of these scientific endeavors is sometimes more polished than the actual laborious and meticulous process it involves. The LHC's journey, from challenges to discoveries. The Large Hadron Collider path, marked by initial difficulties followed by successful recovery and significant scientific achievements, underscores the reality of advanced scientific endeavors. They are not straightforward paths to success, but are often filled with unforeseen challenges that require patience, thorough problem-solving, and persistent effort. This narrative of overcoming hurdles to achieve scientific progress highlights the complex yet rewarding nature of working at the frontiers of knowledge. The machine restarted its operations in 2015 and ran continuously for 3 years. After a brief hiatus, it was rebooted in April 2022 with enhanced capabilities, now operating at a powerful 6.8 tera-electron-volts. This third phase of operation was scheduled to continue until 2026, promising a series of scientific advancements. However, An unexpected event occurred on July 7th during this run, drawing significant attention. The Earth is surrounded by a magnetic field, acting as a shield that protects us from outer space hazards. On that day, a large and unusual gap appeared in this protective layer, and it remained open for an unusually long period, 14 hours. This was not a minor or temporary anomaly. It posed serious questions about the stability and reliability of Earth's natural protective barrier. The Sun, which is a constant source of immense energy, resembles a wild river that occasionally sends strong bursts of energy our way. These bursts are like rapid, forceful waves that crash into Earth's magnetic field. When one of these strong bursts hit us on that day, the already existing gap in the magnetic field allowed more solar energy to penetrate our atmosphere than usual. This event highlighted a significant concern regarding our planet's ability to withstand solar events. Scientists were prompted to investigate this breach thoroughly, trying to understand its causes, its implications, and how similar events in the future could be predicted or mitigated. The occurrence was a clear indication that we might be more vulnerable to solar activities than previously thought, emphasizing the need for continued vigilance and research in understanding Earth's magnetic field. This incident serves as a crucial reminder of the dynamic and sometimes unpredictable nature of our relationship with the natural forces of the universe, urging us to keep probing and questioning our assumptions about planetary defense. Auroras, or the beautiful displays of light in the sky, are like a natural drama unfolding above us, akin to two merging rivers forming a stunning waterfall. On the morning of July 7th, a solar eruption interacted with Earth's magnetic field, sparking a long-lasting light show in the sky. Experts at the National Oceanic and Atmospheric Administration, NOAA, noted that this light show was particularly intense because it followed another solar burst, making the effects even more dramatic. Should we be worried about these solar events? Typically, there is no need for concern. The Earth's magnetic field serves as a strong protector, shielding us from these solar outbursts. Although sometimes imperfections occur, like small cracks in our protective barrier, similar to a window that won't close during a windy rainstorm. Most of the solar energy is kept out, but occasionally, some gets through. This can interfere with our satellites, radios, and power networks. However, these disturbances are usually minor and are often accompanied by the magnificent northern lights, which unexpectedly appeared over Canada and the US during this solar event. More cosmic surprises await as we look to the skies, the increasing spectacle of the northern lights. Scientists have observed that the sun has been more active than usual, suggesting that we might see more of these energy bursts more often. This means that the chances of seeing the northern lights will increase significantly over the next few years, promising more frequent and vivid displays of these natural light spectacles. It appears that the sun is gearing up to put on a continuous show of brilliant colors in the sky, offering us a visual treat while reminding us of the powerful forces at play in our solar system. Meanwhile, in July 2017, the Large Hadron Collider brought to light some remarkable discoveries in the realm of particle physics. These discoveries, although unrelated to the sun's behavior, highlight our ongoing efforts to understand the fundamental elements of our world and the universe. As the sun continues to create spectacular light displays above, here on Earth, scientists persist in their efforts to unravel the complex components that make up our universe, constantly striving to understand more about the world we live in and the cosmos beyond. Despite its achievements, the Large Hadron Collider is not without its challenges. Over time, its capability to make groundbreaking discoveries has begun to decrease. As technology advances, even the most advanced machines begin to show signs of age and reduced efficiency. This decline has made it clear that updates are necessary to maintain the collider's relevance and effectiveness in the field of particle physics. To address these challenges, a major upgrade named the High Luminosity Large Hadron Collider was initiated in June 2018. This upgrade is not a mere improvement, but a comprehensive overhaul intended to significantly enhance the machine's performance. The goal is to enable the Large Hadron Collider to detect even more rare cosmic phenomena, those so infrequent and subtle that they might otherwise go unnoticed. The significance of the Large Hadron Collider stems from its past successes, most notably the detection of the Higgs boson during its initial run. This discovery was a monumental achievement in physics, helping to confirm theories about how particles acquire mass. However, with the new upgrade, scientists hope not only to match but exceed past accomplishments. They aim to ensure that the Large Hadron Collider can continue to contribute valuable insights into the nature of the universe, hoping that its most significant discoveries are yet to come. By revitalizing its capabilities, they seek to keep the collider at the forefront of scientific research, pushing the boundaries of human knowledge about the cosmos. The work involves the Large Hadron Collider, which is set for intense activity. The scientists are preparing to crash particles together with 10 times the force previously used. This isn't just for the thrill of it. The goal is to gather vast amounts of information. By 2042, when this phase ends, they expect to have data sets 10 times bigger than those from the current run. This intense scientific effort aims to shed light on fundamental aspects of physics. The question, however, is what the real-world implications will be. Billions of dollars are being spent to upgrade these giant machines for more powerful experiments. While these investigations may advance our understanding of the tiniest parts of the universe, the direct benefits to everyday people are still unclear. Will the knowledge gained from the Large Hadron Collider lead to practical applications, or is it mostly an intellectual exercise? It remains to be seen whether the discoveries made at such great cost will have any meaningful impact outside of academic circles. The hope is that these insights will eventually lead to technological advancements that improve our lives. But as of now, the outcomes seem uncertain, and we must wait to see if the investment in understanding these tiny particles will pay off in a significant way. Imagine that protons are like bags full of colorful jelly beans. Inside these bags, there are even smaller particles called quarks, which are glued together by the tiniest particles named gluons. When two of these jelly bean bags crash into each other, which they do very often, the jelly beans usually just fly apart. But sometimes, two quarks or two gluons hit each other directly. This direct hit packs all their energy into a very small spot, which then bursts out powerfully. This kind of particle collision happens at the Large Hadron Collider at an incredible rate of 40 million times every second. Think of it like trying to spot a single special spark in a never-ending fireworks display, where every spark could be a clue to a big scientific question. Each collision creates a huge amount of data, like taking 20 high-quality photos with your smartphone at once. To manage this overwhelming amount of information, scientists use a highly advanced computer system. This system is trained to look through all the data and keep only the bits that might show something out of the ordinary. It ignores most of the data because it's just regular, expected stuff. This is important because if the scientists had to look at every single bit of data themselves, they would get lost in the sheer volume of it and might miss the important discoveries. We're not done yet. Let's dive deeper into the universe's hidden sides. The Large Hadron Collider, a quest for invisible forces. The goal is to find those rare and significant events amid the constant noise of ordinary collisions. This is a huge challenge. The scientists need to be very precise in what they look for and how they look for it. They must constantly update their methods and tools to make sure they can catch any potentially important anomalies. This involves a lot of testing, guessing, and sometimes starting over, which can be both tiring and exciting. The process at the Large Hadron Collider is a critical one, where patience is as necessary as the technology itself. Each potential discovery must be checked and double-checked because errors can lead to wrong conclusions. Scientists have to be meticulous and methodical in their work ensuring that they don't get carried away by false leads. The work is slow and requires a lot of attention to detail, but it is essential for learning new things about our universe. The hope is that among the billions of collisions, they might find a few that offer new insights into the laws of physics and the nature of everything. In the world of particle physics, scientists at the Large Hadron Collider are like precise photographers who sort through countless images to find the best ones. They analyze these moments from particle collisions, aiming to find tiny, previously unknown particles that could change our understanding of the universe. These particles are extremely powerful, similar to the strongest boxers who break down into smaller, energetic pieces. The Future Circular Collider, a grand plan. However, in its third round of experiments, the Large Hadron Collider may not directly find these powerful particles. Instead, the scientists are looking for indirect signs that point to these particles, much like finding a map that hints at hidden treasures rather than discovering the treasure itself. These signs could help pave the way for more significant findings in future experiments. Now let's discuss dark matter. It's a big part of our universe, yet it remains invisible. Some of the new particles found at the Large Hadron Collider might be connected to dark matter, although these connections are hard to observe directly. Observing dark matter is like trying to see the wind. You cannot see it by itself, but you can observe its effects, such as leaves rustling. At the Large Hadron Collider, scientists look for unusual movements in other particles that suggest the influence of dark matter. This search is challenging and often feels like searching in the dark, but it continues to push scientists forward, holding the promise of dramatically transforming our understanding of what makes up the universe. Detecting faint signals in the realm of particle physics is incredibly difficult, akin to trying to hear a quiet whisper amid the roaring noise of a rock concert. In its third upgrade phase, the Large Hadron Collider is undergoing improvements to enhance its detectors to better capture these weak signals. However, the scientific community is not just stopping there. Plans are underway for an even larger project, the Future Circular Collider. This would be a massive step up from the Large Hadron Collider, potentially consuming a budget ranging from $9 to $21 billion. This grandiose plan, however, is not without its detractors. Some critics believe that with such a large sum of money, we could instead fund other major scientific projects, such as building a large radio telescope on the less explored side of the moon or developing a detector in space to track cosmic gravitational waves. The noted physicist Sabine Hossenfelder expresses doubt about the benefits of this gigantic new collider, comparing it to investing in a super telescope that may end up not revealing any new celestial objects at all. A journey of discovery. Amidst these debates, the Large Hadron Collider is gearing up not only for its third run, but also a fourth. It seems the physics community is determined to continue this challenging journey, systematically building on small discoveries in the hope that they will lead to greater understanding. Each upgrade and every new run of experiments is a carefully calculated step in an ongoing effort to uncover more about the universe's fundamental workings. These efforts require significant financial investments and scientific commitment, aiming to push the boundaries of what we know about the cosmos. Promises of new insights about the basic workings of our universe are often presented as if they were episodes from an exciting TV series, each claiming to reveal fresh and surprising facts. This was compared to discovering an unknown door in your home. But what else might we find in the future? This constant expectation of new discoveries might appear thrilling, but it also raises the question of whether these findings truly change our understanding or merely add more questions. However, often these discoveries simply contribute a small piece to the complex picture of our universe. Join our channel for fascinating insights into science and the cosmos. Discover the mysteries of the universe, explore the wonders of space, and stay updated with the latest scientific discoveries. Subscribe now and embark on an exciting journey to expand your knowledge and curiosity about the world around us.